Okay, here we go. Calculator inactive. This is number 3, 2016, AP Calculus, free response. So they have given us a graph that you can't see because I just moved the paper. And that graph is piecewise linear function, so these are all lines, so they're not trying to trick you with slightly curvy things. And it goes from -4 to +12 on the x-axis, and g is defined as the integral of 2 to x of f of t dt. That's really good to know. I'm just going to go ahead and start with that idea because we're going to need to talk about g a lot, but they gave us the graph of f. So g is the integral of f, so knowing that g of x is the integral from 2 to x f of t dt, then we could take the derivative, and this is the second fundamental theorem of calculus as it's referred to in a lot of textbooks, but basically the derivative of this side is g prime. The derivative of this integral just gives me f of x, which is really good to know. While we're at it, let's just go ahead and keep this train rolling on the right track, and we have that. So before we ever really even start, we know this much already. So if they ask us things that are related to the derivative of g, we're really looking at the graph of f. So let's just jump in with part A again. Does g have a relative minimum, maximum, or neither at x equals 10? Well, maximums and minimums occur where the derivative equals 0, but I'm going to have to be more specific than that. So I could say, oh, well, the f, which is the derivative of g, does equal 0 here, so I could be like, yeah, it's a maximum. Actually, no, it's not. So let's just start articulating that. So part A. G does not have a max nor a min, you can abbreviate like that on the AP test, at x equals 10. This is true because it rhymes, max or a min, at x equals 10, and here's why. Because, okay, in order for us to have a maximum or a minimum, then the derivative needs to change signs, okay? So this is one of those situations where, just kind of follow me here. I have a graph that goes up and then down, so the derivative would be positive then negative. So knowing that I'm looking at the derivative of g, I have, in this circumstance, a derivative right here, staring at that, a derivative that is positive then negative. So this one would be a maximum, actually. X equals 6 is a maximum of the graph of g. 10, I have a derivative that is negative and then negative, so it never changed directions. The original graph never changed directions. So because f, and I want to clarify a little bit here for the people that are grading my paper, f, the derivative of g. Now, I've written that up here. That was my doodling. They might look up there for a reference, but I think it's a good idea to articulate it. The derivative of g does not change signs. Okay, part B. Does the graph of g have a point of inflection? Points of inflection have to do with the change of sign of the second derivative at x equals 4. Justify your answer. So let's look and see what we're dealing with. X equals 4. We have this maximum of f. Now, here we go. Point of inflection would be second derivative of g, which is the first derivative of f. So here's the question that I'm really asking is, do I have a change of sign of the f graph? And the answer is yes. So let me rephrase that, of the graph of the slope of f. So positive slope, negative slope, yes, we have a point of inflection. So let's write that down. G has an inflection point at x equals 4 because, all right, and here's why, one more time. Let's talk about it again very quickly. The slope of what I'm looking at, which is the second derivative of g, changes signs. So, because f prime, I almost worded it the wrong way. F prime, which is equal to, I could have just written the equal sign, equal to G double prime, changes signs. Okay, there is a little bit of controversy in the way these things are graded. I wouldn't say controversy. People have a hard time knowing exactly what to write in order to get the points that they need to get. So I'm going to word this a different way. Maybe I'm over-explaining, but I think this is going to help us out, at least in our understanding. So knowing that I'm having a change of sign of f prime, I want to really reference what I'm looking at. So one of the things that I have heard a lot in workshops is when you're articulating what you are asked to articulate, let me try it this way. When I'm talking about the point of inflection, I need to talk about this graph. And in that first sentence, I mean, I said what I needed to say, but I was referring to f prime. I'm not looking at the graph of f prime, I'm looking at the graph of f. So I'm gonna sort of back up and try it again. Was I wrong? No, it was a good idea, helped us articulate it, but let's talk about this graph. I know the slope changes, but I'm gonna talk about it a different way based on what I'm looking at. This graph transitions from increasing to decreasing. So, another explanation. The graph of f changes from increasing to decreasing at x equals 4. Okay, we have justified that answer. Let's read part C and see what we're dealing with. Find the absolute minimum value and the absolute maximum value. Let's just stop right there. They're asking for maximums and minimums. I'm just going to start thinking of what I know. With the extreme value theorem, I know that maximums and minimums occur at the endpoints of an interval, looking ahead, and also where the derivative equals 0 or doesn't exist. Okay? Find the absolute minimum, maximum values of g on this interval. Justify your answers. So I need to find the highest and the lowest, and that's going to occur where the derivative equals 0. This is the derivative of g. So here and here. Now you're like, well, what about here and here? This is not going to be a maximum or minimum because I say it's where the derivative equals 0. But to be more specific, it's where the derivative changes signs. Also, it could happen at the endpoints of the interval. So we're going to test a few points here. And so let's just start by justifying our answer. We're going to justify it this way. So g prime, which is equal to f, just good to articulate that, changes signs at a couple places. That's at x equals -2 and at +6. And only at those places. And so we're going to test those. We're also going to test the endpoints of the interval. So -4. So -4. -2, 6, and 12. And we're going to figure out what g is. All right. Knowing that we are dealing with the g that they gave us, which is defined as an integral. Hope you can hear me. Got up. Close the door. It's defined as an integral. We're going to do this. This is the integral from 2 to -4 of f of t dt. And we're going to figure that out. And this is the integral from 2 to -2 of f of t dt. And this is the integral from 2 to 6 of f of t dt. And this is the integral from 2 to 12 of f of t dt. Okay, some of these are easy, some of these are a little bit harder, and they won't be that bad overall. I'm going to start down here at the bottom, actually. Integral from 2 to 12, it's the area. The area from 2 to 12. And I think this is going to be fairly obvious. I mean, just look at the basic symmetry. That's a triangle. This is the same size as that one, but this one is technically positive. This one's negative, has in its area. So these cancel, and the only thing I have to worry about is the area here, which is a base of 2 and a height of -4. So 1/2 base times height, throw in the negative here, means I don't have to worry about counting it as negative because I have already done so. So that ends up being -4. We figured that one out. Okay, now let's figure out the area from 2 to 6. This one should be pretty easy. Area from 2 to 6 is a triangle with a base of 4 and a height of 4. So do it in your head if you want to, but I'm going to write it out. 4 times 4, that's going to give me 8. Okay, now we're going to have the area from 2 to -2. If you want to, you can reverse this, change its sign. So from -2 to +2, f of t dt. And so we'll figure out the area and then just change its sign. So from -2 to +2, -2 to +2 is the same, so it's 1/2 4 times 4. We've already figured that out. We know that it is 8, but I lied because it is now negative. Another way of looking at it is, back to the original, from 2 to -2, if I go from 2 to -2, then I've traveled backwards. So I could say this distance is -4. Distance is never negative, but just from our perspective of the direction we're going, -4 and then 4, okay? And then we're gonna do the area from 2 to -4. So from 2 to -4, well, again, let's look for some symmetry here. That right there, they cancel. So all I really need is this area, which is negative, but I thought positive is above the x-axis. Yeah, but I'm traveling backwards, right? So treat it backwards if you like, or you can treat it like you're going forward and changing the sign, however you want to do it. Since I'm starting at 2 and moving to the left, I will count areas above the x-axis as positive and below as negative. And so I'm going to go from 2 to 0, so that is a width of 2, height of 4. It will count as a negative. So 1/2 2, I'll make that one negative because we're going backwards, and then 4, and that's going to give me -4. All right, so we are looking for the highest, we are looking for the lowest, and I want to be careful that I actually answer the question the way they asked it. So find the absolute minimum maximum value of g, so of the actual function. So I need to respond with the values of the functions. So the maximum value of g on the interval from -4 to 12 is 8. I'm going to get really specific, and I'm going to say it is g of 6, which is equal to 8. And the minimum value, I'm going to be more specific, the absolute maximum, absolute minimum value of g on that interval is, and I'm not going to write all that again, I don't think it's necessary, is the -8, which happens at -2. There we go. All right, one more part. For -4 to 12 interval, find all the intervals for which g is negative or equal to 0. So I'm looking for everywhere that g is negative, and I'm going to just sort of eyeball this one. They did not say justify your answer, which is going to save us just a little bit of trouble here. So here we go. The interval defines the function, and it starts at 2. I'm looking for negative values, negative accumulated area. Just follow me closely here. Let's grab 2 pens. I'm going to start at 2 and move forward. We'll just start this way. I have accumulated a positive area, and now I am losing that area as I move forward. And again, this is a situation where by the time I travel from 2 to 10, I have gained just as much as I've lost. And so the value of g, which is defined as accumulating area, is 0. Now as I move forward from 10 as far as I can go, which ends at 12, then I will have negative area. So the answer to part D, and I can put this on this page, I think I can squeeze this in, save a little paper, is this. The function is -4, and I'm going to list the interval that I just found, and that was from 10 to 12, x values, and potentially there's more, so we can finish this sentence in a second, but just to review what just happened, 0, and then accumulated more area that was negative. Okay, so now I want to figure out where the function has negative area and going the other way. So now as I travel from 2 and backwards, we're going to say, okay, well, as I travel backwards, we're going to have negative area. Oh, so already I know that I have an interval with negative area because I am traveling backwards. And so what would be positive is technically negative because I'm going backwards. So 2, negative area, negative area, negative area, okay? Now I'm gaining some area, but as I gain area, I never gained enough to overcome all this negativity. Look at all this negativity right here. And again, don't look at it above the x-axis and say, "Whoa, no, it's positive." No, I'm traveling backwards. So negative area, quite a bit, and then gained some, but never enough to overcome that. So I'm going to say this backwards, from 2 to negative 4, now let's put it in order. So from negative 4 to 2, and negative 4 to 2. All right, let's score this thing, see what we have. We're going to look at the scoring guide. And part A, the function g has neither relative or minimum since, there we go, there's that phrase. We threw that in there, that's good to know. We threw it up here. We also threw it in here, not necessarily as an equation, but it works. And we said that, we said it doesn't change signs. They said it was consistently negative or equal to 0, which is the same thing. So it's always negative. I said it does not change signs. Points earned. A point for this, which actually occurs in part A, part B, part C, or part D. So anytime you throw that in there, I'm not saying you earn an extra point every time, but you need this knowledge to be displayed somewhere on your paper in order to get that point for these, okay? So point earned there, point earned there. All right, part B. The graph of B has a point of inflection because g prime equals f of x, we've said that, is increasing and then decreasing. So this was the one where I wrote 2 sentences, has an inflection point because f prime, which is equal to g, changes signs, and then I started kind of pausing and saying, well, let's look at what we have. The graph of f changes from increasing to decreasing at x equals 4. That's what they're looking for. Point earned, okay? We had to, part C, consider x equals negative 2 and x equals 6 as candidates. And we did that, and we probably should justify it as well. So we said it changes signs. So far, so good. We considered negative 4 and positive 12. So far, so good. And answered with the justification, and our answer is indeed correct with the correct justification. All right, last one. There are 2 intervals they were looking for. We got them both. Points earned.